All right, welcome to today's lesson in case you missed our WebEx. So I'll quickly whip through what we talked about. So on the Google Classroom, you may have not seen it, there's a GIF that I made from a YouTube video. So we'll just have a quick watch and see what we can make of it. We've got this triangle here in the middle with two parts here, a bigger part at the bottom. It's filled with water, and we notice that the water is running into the bigger part from the two smaller parts. We also notice at the end here that the water is going to completely fill the bottom part. All right, so we can pretty quickly see that the water from the two top parts is completely filling the bottom part. All right, so just going to move forward to there. All right, now this is basically Pythagoras. We've just learnt Pythagoras. Give yourselves a pat on the back. All right, what we should notice from this is that this here is a square, that on the right is a square, and the bottom one is a square. All right, we should also notice that the length of the square is the same as the length of the side of the triangle it's attached to. All right, so there, and there. Now, the bloke named Pythagoras figured this out, and this proof here that I'm showing you is probably the most logical. The others just require a few movements of triangle. To put it into numbers, because maths is about numbers, we know that this side here is a square, and we write that as a squared. What I'm interested in there is that a times a makes a square. This side here we'll call a b square, and the bottom side we'll call a c square. Now, because we noticed that the water from the a square and the b square filled up the c square, we can write it like this. We noticed that the water from the a square added to the water from the b square filled up the c square. All right, so this is Pythagoras' theorem right here. Okay, that means that we can now use this as a bit of an equation to help us find out lengths of triangles. So if we wanted to know the length of this triangle here, and I wanted to know what that side was, I could say I know that the square on this side, 1 squared, added to the square on the other side, which is 2 squared, is the same as the square on that side. Another one I could do, I could say that one there and that one there. I know that 3 squared plus 4 squared equals that side. All right, now hold on, I've just written the answer there. I've got to go through the process. All right, so I know, and remember Pythagoras' theorem said a squared plus b squared equals c squared. All right, so if I was to add these two together, I know that 3 squared is 9, 4 squared is 16. All right, so what's 9 plus 16? Hopefully you say 25. Now that tells me that 25 is the amount of water in the entire square. But I don't want to know the amount of water in the entire square. What I'm interested in knowing is the length of the blue line across here, now purple. All right, I don't want to know the amount of water. So I have to undo this square. And the way I undo it is to use what we call a square root. All right, so I square root 25, and that will tell me what the length of the blue line is. Now this means I'm looking for one number multiplied by itself that equals 25. We should know that 5 times 5 is 25. That means that 5 is the length of x, or the length of the blue line. Okay, so this triangle, if I redrew it, would have a side of 3, a side of 4, and a side of 5. And to show that it works, I could go 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25. Add those two on the left-hand side together, and I get 25 on both sides. And that shows me that I've done it correctly. Okay, so Pythagoras' theorem can help us work out these sides, the length of the sides. The only thing we need to know is that in this theorem, A and B are called the legs of the triangle. C is the hypotenuse, and that is always the longest side. All right, so you notice that C here is the biggest square, A and B are the two smaller ones. You notice that over here on my examples, I used 1 and 2 as my legs, and then this one here, which was obviously the longest side, as my last one. Here in this example, 3, 4, and X, the legs and the hypotenuse. Now, quickly before you go and try some other questions, there's a very particular reason that we can use this in real life, and it's the reason that originally Pythagoras found, was that this particular Pythagoras theorem, a squared plus b squared equals c squared, only works on special triangles. It only works on right angle triangles. All right, so if I have a right angle here, I know that the length of this side, or the square on this side, added to the square on this side, is going to equal the square on that side, only for right angle triangles. All right, so this allows people like builders, when they're building walls, or what typical wall looks like this, with some studs up and down it, some noggins through it. All right, their builders want to make sure that these are square corners here. So what they do is they can measure this side and this side, and then they measure through the diagonal, and they take the square of this side, the square of this side, and check that it is the same as the square of the diagonal. If it is, their wall is square. If it's not, they've got some adjustment to do. All right, so it's used on a daily basis in the building industry. So a question a builder might come across is a triangle or half a wall looks like this, has a side of 4 meters, a side of 2 meters, and this diagonal up here is 3. So we're going to check, all right? So the builder would go, okay, so 4 squared plus 2 squared is 3 squared. Does that look like it's going to be right? This is already 16, and that's 4, and 3 squared is 9. So we're already well off. 20 is not the same as 9. So this builder has completely stuffed up their wall and has not made a square one. They have to restart. All right, so when we answer problems like this, we're looking to lay it out with the 2 legs equals the hypotenuse and see if the 2 sides will equal each other. If they do, we found a right angle triangle. If they don't, we haven't got a right angle triangle. All right, so that's a bit of a crash course into Pythagoras theorem. The last thing that you're allowed to do in this is, if you don't know your squares and your square roots, for instance, the square root of 25 is 5, the square root of 36 is 6, the square root of 81 is 9. What happens if a side is 27 and we had to square root it? Well, that's not a nice square number, so we can just say, oh, well, I can't be bothered, that's my answer. And this is called an exact value, because this is a lot more exact than converting it into a decimal. All right, so if you found that you had a 27 as your c squared, you could say, okay, I know the length of the triangle side is then the square root of whatever that number is, which I'm not really sure at this stage. I'll just leave it like that. Okay, so a little bit of a shortcut that we're allowed to take there. So hopefully that makes sense to you, starting with this proof where the 2 squares add together to make one larger square, moving into the calculations we're allowed to do around it.